Let's solve LeetCode 167 to sum 2. Input array is sorted. Given a one-indexed array of integers numbers that is already sorted in non-decreasing order, we need to find two numbers such that they add up to a specific target number. Let these two numbers be numbers at index 1 and numbers at index 2, where 1 is less than equal to index 1 is less than index 2 is less than equal to numbers.length. We want to return the indices of the two numbers, index 1 and index 2, added by 1 as an integer array, index 1, index 2 of length 2. The tests are generated such that there is exactly one solution. You may not use the same element twice, and your solution must only use constant extra space. Every sentence in this problem is telling us something about the problem. So let's go ahead and look at an example. 2, 7, 11, 15 is the numbers given to us. Target is 9. And this is an example which is quite similar to the two-sum problem that we solved in this one. Cool. So how exactly are we going to solve this? Well, the two-sum problem tells us that we can solve this in O of n time complexity. And yeah, we do need O of n time complexity because to find out what the two numbers are that add up to the target, we need to understand what are all of the numbers in place, right? So in the worst case, we'll have to go through all the numbers. That's not something we can optimize. The time complexity we are going for is O of n, but the space complexity we are going for, that can be changed. How? Because we have one additional constraint with us. In two-sum, the input array was not sorted. In two-sum 2, the input array is sorted. So we need to make sure that we take use of that sorted array and use it somehow. So that is going to be the trick to reduce the space complexity. So the space complexity will go from O of n to O of 1 because in two-sum problem, we used a set to reduce the the space complexity, sorry. So here we need to ensure that we can remove the dependency on that set. And the key thing over here is that we are going to use two pointers technique. Once it just clicks that, hey, we need to use 2 pointers, you'll be able to solve this problem really quickly. How? Let's take an example. So I'm just going to copy this and put it out over here. So these are the numbers 2, 7, 11, 15. Our target is 9. Okay, so let's make note of that as well. Cool. So how are we going to find out and how are we going to take advantage of this, sorted array? And by the way, it's always in an increasing order or a non-decreasing order. It's always going to increase. Okay. So how are we going to do this? Well, we know that 2 plus 7 is going to give us 9. Okay. So that's equal. Luckily for us, in the very first try, we'll be able to get it, but not using the approach. But anyways, I don't want to confuse you. Let's see another example. 2 plus 7 is equal to 9. So that's our answer. So we are going to return at that time. Let's say we have 2 plus 11. That is equal to 13. In that case, what do we do? Listen, the array is sorted. If the array is sorted, I know that I need to go backwards in time, right? I mean, not in time, but backwards in this array because 2 plus 11 gave me 13. This is telling me that the array, if I just go further, for example, to 15, 2 plus 15 is only going to increase. We're not going to get close to our target. If we want to get close to our target, we need to go back because it's an array that's ascending. Cool. So that is the biggest insight that we need here. As simple as it gets. Now, how are we going to make this insight useful? Using two pointers technique. How? Let's see. So the very first thing that we're going to do is have our one pointer, the beginning pointer at the beginning of the array, and another pointer which will be towards the end of the array. And then we'll add the number at the left pointer and the number at the right pointer. So what we have is 2 plus 15. That gives us 17. We'll compare that with 9, which is our target. And then we see, hey, 17 is greater than 9, right? So if I want to reach towards 9, what do I have to do? I want to get towards the beginning of the array because that's where my answer is going to lie, right? So what we are going to do is tell that, hey, take my right pointer and just move it to the previous element. So now our left pointer is at 2 and our right pointer is at 11. Notice my left pointer does not change, only my right pointer changes, and the reason for that is because I want to move towards 9. To move towards 9, I can make use of that sorted array and go towards 9. Cool. Now what I can do is 2 plus 11, which is equal to 13. If we compare 13 and 9, what is the case? Well, 13 is still greater than 9. That means I have to take this right pointer and move again towards the beginning of the array. So I move to one previous element. Okay. And now again I check 2 plus 7, which is equal to 9. Let's compare it with 9. And yes, it is equal. So we just return the index at this pointer and the index at this pointer. That is our answer. By the way, we need to do plus 1. That's given over here. So it says, let these two numbers be this and this, where 1 is less than equal to index 1 is less than index 2 is less than equal to numbers.length. We want to return indices added by 1. So instead of returning 0 here, because that's the index, we're going to return 0 plus 1, and the same here, 1 plus 1, 2. Cool. Now let's try this out on a different example. Let's take the example, well, all of these examples are quite easy actually. I want to take a more complex example to give an intuition. So let's say I have 4, 6, 8, let's say 15, 20, 22. Cool. So this is ascending order, and let's say our target is 12. Now looking at this, you might know, actually let's not take 12. Let's say 23. Okay. So just looking at it, you know the answer, but computers are useful when you have bigger data sets, not smaller, but just for our understanding, let's go ahead and see this in action. So left is equal to the 0th index, right is going to be equal to the length of array minus 1, because we want to point at index number, let's say 0, 1, 2, 3, 4, 5. So this is index number 5. The total number of elements are 6, but the index this will point at is 6 minus 1, which is 5. Cool. Now let's see. So we do 4 plus 22, which is equal to 26. Let's compare it with 23. Well, 26 is greater than 23. So what I'm going to do is take this arrow and move it to one previous element. Now I do 20 plus 4, which is 24, right? So let me just put it in. 24 is still greater than 23. What do I do then? Well, I'll just move this arrow again to the left hand side, one previous element. Then I compare 4 plus 15. What is that giving me? 19. 19, and compare it with 23. 19 is smaller than 23. If it is smaller, then that means we want to increase the value of the two numbers that we have. So when we added the two numbers, the value was smaller than the target value. So we want to increase the value. So to increase the value, what we can do is just go one step forward. Now we have 15 plus 6, which is equal to 21. Okay, so 21, compare it with 23, it's still smaller. So now what we'll do is again move right arrow forward. Cool. And finally, after this, we have 8 plus 15, which is 23. And since it's equal, we'll return. So that is our solution. We made use of a very simple trick that if it's increasing, I'll just move the number slightly towards the correct value, one step at a time. So first we got 26, 24, and then we suddenly went to 19, but then we got closer and closer to our value again, and then ultimately got the answer. So the time complexity of this remains O of n, but the space complexity is just O of 1 because we no longer need a set. We can make use of the sorted array to ensure that we only have to keep track of these indexes, which are two integer values, which is just O of 1. So let's go ahead and solve this. The first thing that I'm going to have is a left pointer and a right pointer, which is equal to 0, length of numbers minus 1. So they're pointing at the left index and the right index respectively. After that, we'll just check while left is less than right. The reason I'm checking left is less than right is because let's say the left exceeds the right. That means this left goes somewhere over here. If that is the case, we've already messed up. That means there's no solution, but we'll never really reach that case because here in our problem, it says that we are guaranteed to have one solution. So that's good. After that, what we can do is compare the value. Now to compare, first we need to do the summation of the two values. So I'll just create a variable called summation, which is equal to numbers at left plus the numbers at right. And then I can check, hey, is the summation greater than the target? And we notice that, hey, if the summation is greater than target, I want to move my right pointer a little bit towards left. So what I'll do is right minus equals 1. Okay. The other case that we can have is summation is less than target. If that is the case, then left will increase by 1 because now we want to increase the value to be more towards target. So we can just go forward in the array and we'll get a larger value. And after that, there's a condition of summation being equal to target. And if that is the case, we found our answers and we'll just do return L, R, correct? Nope. We'll do L plus 1, R plus 1 because we want to increase it by 1 and then return it. And that will be our solution. Now, since it said that we are only going to have one solution, that means we will never have no solution. We are not going to return anything after this while loop. But if you want, you can return it. But the fact is we'll never reach this statement because we'll always have a return statement executed. Cool. And now let's run it. Accepted. Let's submit. And that works out as well. So one key thing to remember here is that whenever you use two pointers approach, it doesn't necessarily mean that you need to increase both the left and the right hand side pointers. No, it can be the case that only the left increases or only the right increases, or it can also be the case that both of them move. Okay. So just make sure you have that in mind about two pointers, especially when we solve problems ahead. For example, 3-sum. So let's get started with the 3-sum problem now.